Okay, we're coming almost to the end of the line here with a illustration of our profit maximization rule. What I want to point out before we erase most of this is that, again, our average fixed cost curve starts high, drops like a stone, and gradually tapers off. No U-shape. Average variable cost, as we increase output, starts high, goes lower, it bottoms out, and then it goes back up as we increase output. And what we see with the average total cost curve, it starts high, comes lower, lower, bottoms out, and it also comes back up again. What we didn't mention is now we've got another curve here. We've got another set of costs called marginal cost, the cost of producing the very next unit. And again, over here, remember we said accountants are always interested in what's going to happen next. We're always interested in the future. We're not interested in the past. And by the way, we need the accountants to give us this information on variable cost. That's where we get this information. So we need our accountants to do that and tell us what fixed cost is. And once they do that, we're going to apply the profit maximization rule. But notice here, our marginal cost curve starts high, and we needed this one in order to show that it also has a U-shape, bottoms out, and then it comes back up again. So what I'm going to do now is I'm going to erase all this stuff that got us to this marginal cost column here, and I'm going to move this column of output right over beside it, so it's right next to it. And even though I know they're between the lines, I'm going to put them right on the line simply to make it match up perfectly, and it's kind of an experiment, so we'll see how it goes here. So I'm going to erase this all the way over to this right here. Then I'm going to take my outputs over here. I'm going to try this. This was, I'll just put 0. This is quantity, 0, 1, 2, 3, 4, 5, an output of 6. Now again, I had 7 down there before, but I had to move it up or down with our 0. I could put 1, 2, 3. I'm not sure which way to do it now. We'll just guess at that one. So I'm going to erase this. And what we know is that we have an average variable cost curve that looks like this and bottoms out here. We have an average variable cost curve that looks like this. Average total cost curve looks like that, which bottoms out past that point, if I draw it correctly. And notice here that we bottom out very, very early with our marginal cost curve. It also has a U-shape that bottoms out before the bottom of the average variable cost curve and before the bottom of the average total cost curve. And here's what is so interesting. Our marginal cost curve goes through the very bottom, the extreme bottom point of both our average variable cost curve and our average total cost curve. That will happen every time. Every time without fail. Every time, absolutely every time. Now, why does it happen that way? Well, we said the marginal cost is the cost of the sale or the production of the very next one. Think of it this way. Let's say we've taken some tests, and we got a 90% and a 90%, which means our average is 90%. But if on the very next test, our marginal test is 100, it's higher than our average, well then it's going to bring our average up. But if we have an average of 90% and the next test is a 60%, then our marginal test is going to bring our average down. Similarly, if our marginal cost, the cost of producing the very next one, If our marginal cost is below the average variable cost, it's going to bring it down. It's also going to bring our average total cost down. As long as the marginal cost is below the average, it brings the average down. Now, if we have an average of 90%, and our very next test, our marginal test, is 90%, it doesn't move our average up or down. But if our next test is above 90%, it tends to bring our average up. That is why the marginal cost curve will always go through the very bottom of both the average variable cost curve and the average total cost curve. So when we're up here, for instance, at this point right there, in which the marginal cost at this output right here called QX, we're producing that many units. We've already produced units 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We're up here to unit 20 at an output of 20, just for an example. This is our marginal cost, which is higher than our average total cost, which is higher than our average variable cost. So at this output, the marginal cost is bringing them both up because our marginal cost is above them both. Over here at an output of, say, maybe 5, it's bringing our average total cost down, and it's bringing our average variable cost down. There is only one section in which we have a strange phenomenon, and that's between this point and this point. When the marginal cost is somewhere in between those two curves. When the marginal cost is between the two curves, it's bringing this average variable cost curve up. At the same time, it's still bringing the average total cost down, and that's because it's precisely between those two curves. Now, let me just state the revenue maximization rule. Remember we said that we put a dollar sign here because we're not just talking about prices and quantity, we're talking about costs and quantity as well. We're talking about cost and price up here. If we had a price at this level here, a price at that level here, and again we can pick whatever price we're at here, our profit maximization rule says that we want to pick the price. Could be this price, this one, this one, this one, this one, this one. I'm sorry, I said that wrong. We want to pick the quantity. There we go. We're going to pick the quantity at which marginal revenue equals marginal cost. Which marginal revenue, let's do some definitions again. We know what marginal cost is. That's the cost of producing the very next one. What's marginal revenue? Well, it's the revenue that comes into the cash register when we sell the very next one. Well, when those two numbers are equal, we want to pick this Q down here. Could be Q1, Q3, Q5, Q6. Which one of these outputs, where should we produce? Should we produce a lot, an average amount? Should we produce a little? How much should we produce in our factory to maximize our profitability? That's the essence of the profit maximization rule. Which we pick the Q at which MR, marginal revenue, equals marginal cost. So let's go back to marginal revenue. We said that when we sell one more, what do we sell it for? Well, we sell it for the existing price. What if we sell one more? Well, we get that much more into the cash register because that's the price per unit. Oh, so that means that price and marginal revenue are exactly the same thing. Because when we sell one more, we get the value of one more price. Sell one more, the value of one more price. One more, the value of one more price. And so at this level right here, we could say that's also the demand curve. That's also the demand curve. But let's not go quite there yet. I'm going to go there just a second. Now, if we apply this profit maximization rule, we're going to pick Q1, Q2, Q4, Q5, Q6, some number down here at which P or MR, they're the same thing, at which they're exactly the same. So we know this is the price level, call it $1,000. That's the price. Now, as we come across over here, how far do we have to go over here until our marginal cost gets all the way up to $1,000? Well, it looks like it's kind of like right here. I'll just move it over so it's Q6. I had to bend it a little bit, but Q6. So what we're saying here is that if this is the cost structure of our firm, then we will tell the plant manager, here's what I want you to do, plant manager. We can sell as many of these things as we can produce. There's no problem with that. As many as we can produce, people are going to buy them. Now the question is, how many should we produce to maximize our profit? Should we produce 1? Should we produce 1 million? 100,000? How many should we produce? And the answer is we should produce that quantity. We pick that quantity at which this dollar amount, which is our price, equals this dollar amount. And that happens to be true right here. At this quantity, we say, well, what's our marginal cost? Well, we go straight up and we read it off. Oh, it's $1,000, which also happens to be our price. Which means that if the going market price is 1,000, then we want to pick Q6. But what if the market price goes up higher? Say it goes up to 1,200. We can't control the price. Prices go up, prices go down. We're still making the same amount. Do we like it when prices go up? Yeah, we love it. Because now we get to make more. Do I want people to buy my product for $1 million a piece or $10 a piece? I want them to pay me $1 million for every one that I make. I love it when the prices go up. So when the prices go up, we apply our profit maximization rule. So at $1,200, we come over here and we hit MC, and it says we should increase our production that much, up to Q7. But what happens if the price of our good in the marketplace goes down? It's still, I don't like it, but okay, it's going down to $700. So we come over here at $700. We hit our marginal cost curve. We come straight down. Oh, we're going to reduce our production down here to Q5. Q5. So let me back up a second here. We want to be at that output, that quantity at which this equation is true. At which this equation is true. Let's say I'm running my own company. And I produce stuff. And since I'm running my own company, I can produce as much stuff as I have time to produce. And so I worked hard, Monday through Thursday. So I decided I want to sleep in a little bit on Friday. Alarm clock goes off. Hit the thing. And all of a sudden, wife says, hey, Friday? Are you going into work today? Well, I was going to go into work today, but I work pretty hard Monday through Thursday, and they can take care of business. I just said I don't really care about it. I told the guys I'd call them if I want to go in because we were working all day. We're all thinking about taking a day off anyway, and so I just think I'll sleep some more. Wait a minute. How much do you sell your products for? Oh, well, I sell them for $1,000 a piece. Yeah. That's how much you can bring home? Well, no. What you sell them for, that's the money you bring in. That's called revenue, but it costs you something to make them, and those are called the costs of production, and you have to subtract your costs from your revenue to get your profit. Oh, Well, how much does it cost for you to make those things? Oh, don't you start it too. I've had this conversation with my accountant. My accountant says, what do you want? Do you want average total cost? You want average variable cost? You want average fixed cost? You want marginal cost? Which cost do you want me to give you, boss? And I go round and round. I said, just tell me. How much is it going to cost to produce one more unit? Oh, well, that's marginal cost. Why didn't you tell me you wanted marginal cost? I'll tell you marginal cost. Well, if that's what you want to do, what's it going to cost you if you go in today and produce one more? Well, if I go in today, it's going to cost me $400. That's my cost to producing one more unit. And you're just going to lay there? I mean, you're not going to go to work or anything? No, I'm pretty tired. You mean if you went in and worked today, we could have $600 in our checking account that we don't have right now? Yeah, that's the bottom line of it. Get in there. Do you know this family needs that $600? You think of all the fun we could have. We could take the kids up to Cedar Point or whatever and spend that $600. You just want to lay there. Okay. I'll go to work today and I'll bring home the difference between my marginal revenue, which is the price, and the cost of producing one more unit today. Saturday morning. No alarm clock goes off, but hey, yeah. Since you run your own business, if you want to go in and work on Saturday, I mean, it's your business, you can do that, right? Right. So we could use another $600, sweetheart, because, prices are going up all the time. And why don't you go in on Saturday and bring home another $600? Well, sweetheart, it doesn't work that way. What do you mean it doesn't work that way? You just told me that if you worked yesterday, you went in, you brought $600 home for working that day. Why don't you bring another $600? No. You see, marginal cost doesn't stay the same. The more you increase the output, the more it goes up. And when I work on Saturday, I got to pay the help time and a half. I've got special costs for transportation. A lot of businesses aren't open, so we got behind. And it just cost us more to work on Saturday than on a regular Friday at the end of the week. Well, how much more is it going to cost you? Well, it's going to cost at least $600. Oh, so if you go in today on Saturday, it went from $400 and to produce the next one on Saturday, it's going to cost you $600. Is that right? That's right. Well, we could use that $400. Would you go get us that $400, please? Okay. Where's you? I'll do it. Okay. Sunday morning. We went to Mass last night or something like that. We'll go to late service, whatever. Hey, by the way, you're allowed to work on your firm any day of the week you want to, right? Yeah. So technically, you could go in there and you could produce another one here, even though it's Sunday, right? Well, yeah. And I know that the marginal cost keeps going up the more you produce in a week, but if you went and produced another one so the family could have more money, how much money could you bring home? Well, on a Sunday, it's pure overtime, and my marginal cost is going to go up to $1,000. Let me see here. If you go in and you work, you can sell what you made for $1,000, but it's going to cost you $1,000 to produce one more on a Sunday. Sleep on, my beloved. Because there's no additional profit to be squeezed out of that work week starting on a Monday. So that's why we stop. We increase our production until our marginal cost goes all the way up to hit our price level, and then we stop. Well, what if we don't have enough common sense to stop? What if it's Wednesday and we're already up to this point and we got a couple more days to work? Well, we can work those days, but our marginal cost is going to continue to go up, and let's say it takes us up to $1,200. To make that next additional unit, it's going to cost us $1,200, and we can only sell it for $1,000. Is this one hard to figure out? If we're all the way up here, we need to reduce our output to bring this number back down to equal our price. But if the price happened to go up to 1,200, oh, okay, we'll produce more if the price goes up to 1,200, because that would be using our profit maximization rule. So let's say that based upon the data that we had before, what we're actually doing is we have a price that's dictated to us by the marketplace. In other words, we're producing something that other people produce. We can sell as much as we produce at the going market price. We can't affect the price one way or the other. So how much should we produce in order to maximize our profit? We should produce up to the point that we get to this curve and then stop. But what if those nasty foreigners come in here and they start selling the same stuff for less? Well, then we will make less money, and we will want to produce less to maximize our profit. And what if they continue to come in and produce at a lower price? Well, we're going to continue to back off on how much we produce to match our profit maximization rule. And what if they come in and they come in at a price that exactly matches our average total cost? At that point, we've got a decision. We'll call this, I don't know, $1,000 a unit. Again, just use a nice round number. We can produce this many at this marginal cost, at this average total cost, as a matter of fact. We can say you add up the total cost, you divide it by that quantity, and you get $1,000. On the average, that's what it costs to produce it. But the price is only $1,000. Well, wait a minute. If the going market price is $1,000, and we have a cost that costs us $1,000 for every one we produce, what do you think we should do? Radio Land? Do you think we should continue to produce these at no profit? Or stop? At least somebody out there says that doesn't make any sense to go to work and the company not make any money, right? So our friend, the entrepreneur, goes home and tells his wife, those people on the other side of the world are driving down the price so low that my company can't make any money. So if I can't make any money at this thing, the company's breaking even, I'm not going to run the company. Wife says, yeah? So, wait a minute. Let me ask you a question. Is this company paying for your salary? Is your salary included in the total cost of this company? Oh yeah, total cost is everything. That includes my salary. Last time I checked, I think you're making over $60,000, $70,000 a year. Is that right? Yeah. Do you have another job out there that you're not telling me about? No, I just told you the company's not making any money, and so I'm shutting her down. So you just fired yourself from your own $70,000 a year job? Yeah. Huh. Does that make a lot of sense? No, it doesn't make a lot of sense. So as long as he's covering his own cost, his own salary, this firm will continue to operate at zero profit. This point at the very bottom of the average total cost curve is called the break-even point. Called the break-even point. Now, what happens? Oh, I've got a lot of lines in here. I'm tempted to get rid of some of these things just because there's so many lines in here. Yeah, let me do it just because there's so many lines in here that it's going to be hard to follow here. Average variable cost, average total cost and marginal cost. This is dollars over here, quantity here. What happens if the price comes down, come down, come down? Well, we're going to follow our marginal cost curve all the way down to here. We said we would stay in business. At this point right here, at this quantity, how much is our average variable cost? Well, it would be this much right there. How much is our average fixed cost? It would be this much right there. Add our average variable cost to our average fixed cost, and that takes us up to our average total cost. But what happens if the market out there brings the price all the way down to this level here? If we say, okay, well, we're going to produce where MR, which is price, equals MC, well, then we're going to be producing at an output at which our average total cost is higher than our price. Let me think about that for a second. Our price is $1,000, this level. Our average total cost is $1,200. So, because at this output right here, our price at $1,000 is less than our average total cost, which means we're losing $200 on every one that we produce. Now the question of the class is, what's the company going to do? Now are they going to continue to operate? And the surprising answer is yes. Even though the firm is losing $200 on every single sale, this firm will continue to operate. Now that doesn't make any sense, does it? Why are they going to continue to operate to take a loss? Didn't we say over here that if we get very much of this red ink, this loss, that this company is dying and doesn't have very much time to live because it's losing all this money? Yes, we did say that. So why is this company going to keep on operating? The short answer is, at this output, called QX, it has covered all of its average variable cost. But it has not covered all of its average fixed cost. It's only covered like half of it. But if we shut it down, we wouldn't have any variable cost, but we would still be paying out something on our average fixed cost. So, price is below what it cost us per unit to produce. We got a factory here. It costs us $10,000 a month to have the factory. We're locked into the lease. We can't get out of the lease. We're losing $200 on every one that we produce. We're saying, well, when I bring the people in, I'm making enough money to pay all the laborers. I'm making enough money to pay for all the raw material. But I'm not making enough money to pay off all of the rent. It only pays off half of the monthly rent. Should I continue to operate even though I'm taking a loss and I only have enough money to pay half of the rent? And the answer is, well, yeah. Well, why? Because if you shut it down, you're going to have to pay all of that out of your pocket. So do you want to pay all of it out of your pocket, or do you want the company to pay at least some of that fixed cost? And the answer is, well, if it's paying for some of the fixed cost, at least I can minimize my losses over the short run. For a small amount of time, I can minimize my losses by operating in this range between the average total cost and the average variable cost. Now, what if it comes all the way down to the bottom of the average variable cost curve? We can't pay any of our rent. That's coming out of our pocket. And now it's going, we can't even pay all of our help. We can't even pay for all the materials. At that point, right here, call it point A. Call this point B. Point A is the plant shutdown price level. If the market price gets low enough down to here, we say shut our doors. This thing isn't even paying, not only is it not paying the lease, but it's not even paying for all the raw material and the help. So we're better off shutting down here than even keeping our doors open, because now it's not paying any of our fixed cost.